Hello students, this is Varun. In previous video we have studied about section formula which enables us to find the coordinates of point P lying between point A and B such that point A, P and B are collinear and point P divides line segment AB in m/n. Then by section formula, coordinates of point P are x coordinate is m into x2 plus n into x1 whole divided by m plus n, and y coordinate is m into y2 plus n into y1 whole divided by m plus n. And today we will discuss some special cases of section formula. Let point A, B and P are collinear with the coordinates of point A x1 y1, that of point B x2 y2 and that of point P are x and y. And let point P intersects line segment AB externally in such a way that the ratio of AP ratio BP is m ratio n. Now this is the case when P divides line segment AB externally in m ratio n. In that case, the coordinates of point x will become m into x2 minus n into x1 upon m minus n, and the y coordinate will become m into y2 minus n into y1 whole divided by m minus n. So this is the first special case for section formula. Now there is one more special case. If P is midpoint of line segment AB, in case P is midpoint of line segment AB, then ratio of AP and PB will become same. So we can write it as 1:1. And we know that by section formula, x coordinate of point P is m into x2 plus n into x1 upon m plus n. It is the case when ratio is m ratio n, and y coordinate is m into y2 plus n into y1 whole divided by m plus n. Since AP ratio PB is 1:1, so I am going to replace m and n by 1 each. So from this, the x coordinate will become 1 into x2 means x2 plus 1 into x1, it will again become x1 whole divided by 1 plus 1, that is 2. In the same way, y coordinate will become y2 plus y1 whole divided by 2. So we can say that if P is midpoint of line segment AB and the coordinates of point A are x1 y1 and that of point B are x2 y2, then coordinates of point P are x2 plus x1 upon 2 and y2 plus y1 upon 2. Now we will do some sample questions to understand the concept of section formula in a better way. And the first problem is, find the coordinates of the point which divides the join of coordinates of first point are -1 7 and that of second point are 4 minus 3 in 2:3. Let -1 7 represents point A and these coordinates represents point B. So let us draw the line segment AB, where the coordinates of point A are -1 7 and that of point B are 4 minus 3. And we have to find the coordinates of the point which divides the join of line segment AB in 2:3. Since it is given that line segment divides the join of these points in 2:3, they haven't mentioned internally or externally, but since they have mentioned that it divides the join of these line segments, so obviously this point, required point, divides the join of point A and point B internally only. So let us suppose that P is the required point which divides the join of point A and point B in 2:3, and we have to find the coordinates of point P, and let the required coordinates are x, y. So we mention in a way that let P x, y is the required point such that AP ratio PB equals to 2:3. Now next we will use the section formula. So by using section formula, we will mention using section formula, the coordinates of point x, the coordinates of x coordinate will be m into x2 plus n into x1 divided by m plus n. Since the value of m is 2 and x2 is 4, n is 3 and x1 is -1, whole divided by sum of ratios, that is 2 plus 3. That is how we get 8 minus 3 upon 5, that is 5 upon 5 equals to 1. In the same way we will solve for y coordinate. On solving, y coordinate will become 3. So coordinates of required point P will become 1, 3. So this is the required answer. Now let us try one more question, and the question is, find the coordinates of points which divides the line segment joining point A with the coordinates -2, 2 and point B with the coordinates 2, 8 in 4 equal parts. Well students, let us suppose that this is line segment AB with the coordinates of point A -2, 2 and that of point B are 2 and 8. Since we are required to divide line segment AB in 4 equal parts, so to divide given line segment in 4 equal parts, we need 3 points. We need 3 points for that. So let this point is P, this is Q, and this point is R. So 3 points P, Q and R lie on line segment AB such that they divide line segment AB in 4 equal parts, which is AP, PQ, QR and RB. Since length of AP, PQ, QR and that of RB is same, so it is clear that point Q is midpoint of line segment AB. And if Q is midpoint of line segment AB, then coordinates of point Q are given by the midpoint formula, which states that if P is midpoint of line segment AB, where coordinates of point A are x1, y1 and that of point B are x2, y2 and coordinates of point P are xy, then x coordinate of point P is given by x2 plus x1 upon 2 and y coordinate is given by y2 plus y1 whole divided by 2. So using this, we get the coordinates of point Q will be, x coordinate will be -2 plus 2 divided by 0 and that of y coordinate is 2 plus 8 divided by 0, which is further equals to minus 2 plus 2 is 0. 0.2 is going to be 0. And 2 plus 8, 10. 10 divided by 2, 5. That is how the coordinates of point Q will become 0, 5. Now it is clear that P is midpoint of AQ. Similarly, R is midpoint of QB. So by applying the same formula, we can find the coordinates of point P and that of point R. That is how the coordinates of point P will be, x coordinate will be minus 2 plus 0 divided by 2. In the same way, y coordinate will be 2 plus 5 divided by 2. That is how coordinates of point P will become minus 1 and 7 upon 2. In the same way, coordinates of point R will be, since R is midpoint of QB, so the x coordinate of point R is 0 plus 2 divided by 2, and y coordinate is 5 plus 8 divided by 2. So on solving, the coordinates of point R will become 0 and 13 upon 2. So the required solution to the given question is P with the coordinates minus 1, 7 over 2, Q with the coordinates 0 and 5, and point R with the coordinates 1 and 13 upon 2. This is required set of points which divides joint of line segment AB in 4 equal parts. Well students, there is one alternative way to do this question, that is by using section formula itself. Since AP equals to PQ equals to QR equals to RB, so it is clear that point P divides line segment AB in 1:3. So by applying section formula at point P, we can find coordinates of point P. In the same way, point R divides a join of line segment A and B in 3:1. So again, by using section formula, the coordinates of point R can be found. In the same way, coordinates of point Q can also be found. So today's session is over here. In coming session, we will do area of triangle by using coordinate geometry. We will also work to find the coordinates of centroid of a triangle. Thank you.